This is Mad Hacker 2000, and I'm going to do a complete tutorial on how to replicate the effect that I've just shown you. Now, as I mentioned in my last video, my batteries were overcharged to 6 volts. As it currently stands, they are at 4.2 volts, and they are powerful enough to make this LED light, but not very brightly. And as you saw in the last video, it was glowing very brightly. So, I'm going to show you how to duplicate the effect now. All you need is 2 rechargeable batteries. In this case I'm using NiCads, and 2 regular batteries. It helps if you have 4 of the same kind of batteries so that you can swap them back and forth, as these non-rechargeable ones will eventually die out. So what I'm going to do is I have 2 of these batteries in series, and I'm going to connect this one in parallel. And I'm going to connect it through my meter so I can show you exactly how fast it's charging. Now normally, when you use a wall outlet, it could take several hours, according to my batteries here, depending on the current. It can take 14 to 16 hours or 4 to 5 hours. And what I'm going to show you here is when you charge them this way, it could take anywhere between 10 and 20 seconds. And the last ones that I used in the video, I had only charged for 6 seconds apiece. And if I were to put them in a remote, I would get way more than 100 channel presses off of a charge like that in one of my tests. So what I'm going to do now, and again I apologize for the quality, I'm going to switch this to 10 volt scale and connect the battery for charging. As you can see, it's registering just under 6 volts there. And I connect my battery negative to negative and positive to positive. Now what you'll see is that as soon as I connect it, there's a drop in the voltage. So what you want to do is keep charging it. As you can see, it's at about 4 volts right now. That's about as much of a charge as one of these is going to take, considering it's only a 1.5 volt battery. So I'll replace it with the other one. Give that one a little quick charge. As you can see, that one is a little bit lower than the other one. And now, if I replace these ones, the ones I've just charged, and hook up my LED again, I think you'll be able to see a difference. Well, I accidentally shorted them there, and that can be a good thing because I can show you now more accurately how the meter moves. Shorting them with this kind of charge appears to be very bad for it. The more resistance you have in a load, the higher the settling voltage that it will maintain. As it stands with my last one at 4.2 volts and about 20 milliamps, it's producing about 84 milliwatts of power constantly. So now, when I connect these batteries, current rises fairly quickly. As you can see, that's very bright. Now if I were to leave it like this, it would stay this bright for a while, and then it would settle down to the other brightness that I showed you. I could demonstrate some of the properties of this. Using my multimeter because it has circuits at various resistances. So if I put it in off, it won't do anything. But if I turn it to 10 volts, you can see it is registering about 5. It's halfway across. But the minimum threshold voltage is 4. So it is slowly discharging right now, and the LED is still lighting brightly. And if I turn it down another scale to discharge some of it faster, you can see that it will start to dim. Now I can dim it all the way past the voltage required to shut it off completely, and then it will come back on. I'm actually going to do something a little more dramatic. I'm going to short out one of the cells completely. As you can see, I just disconnected that and it went back up to its full brightness. But now, as you can see, I have my multimeter connected across one of the batteries, and what I'm going to do is completely short it. And to show you the effect, as soon as I switch it here, it's going to completely go out. And out. Now as soon as I turn it off, it goes back on. If I were to do that with both of the cells, it would take some time for it to recharge, but I'll show you again. 3, 2, 1, off. As soon as I go back. Now what that's doing is it's designed to measure a current that has very low resistance, so it immediately shorts it out. If I was to short out both of them, then it would take some time for them to recharge, but this one acts in helping the other one to recharge. So what I'm going to do is do that one more time. 3, 2, 1, out. Except for a little longer. Now look at the voltage scale as it started to light back up. I'm going to do it a little longer this time. Out. At 2 volts, and it's starting to come up on 3. So it's just measuring one battery, remember? So this one battery has 3 volts, as opposed to a regular one. I'm going to explain a little bit of the theory behind this. It's not actually new, it's actually kind of old. Tesla discovered that if you have a battery and a load, say this load is a lamp at 1 amp, and 1 amp goes in and 1 amp goes out. And conventional electrical physics accepts this as standard. Yet, that's perfectly good usable energy that we merely use to destroy the inside of the battery. Now, a battery is not what we commonly perceive. It's not a storehouse of energy. It is actually a focal point into the 0 point energy field.